Power, an essential commodity for any electrical system to work. With ever-increasing demand for power, whilst its environment pollution consequences, distributed power generation and renewable energy sources are fast becoming inevitable.
At Ltts, we had the mandate to design a stackable inverter solution with a wide range of rating essential for power conversion and storage industry.
The heart of this system is a DC to AC converter that generates high-quality power with standard voltage and frequency that can be fed back to the grid. It can also store excess power in a battery storage system. Small appliances such as table saws, refrigerators, medical equipment, automobiles and microwaves work on low-power inverters but have specific surge requirement and pure sine wave output.
Every appliance and application is different. The challenge for an inverter designed with configurable and scalable parameters for multiple domain and varied power requirements was huge.
We developed a low-cost modular stackable three-phase inverter that can be stacked in parallel to create a larger rating inverter system. It can be connected to grid or a workstation standalone.
This solution is the building block that can be configured for building a variety of applications such as standalone inverter or a grid tie inverter, energy storage system for a microgrid for conventional wind and solar energy that can store power into batteries and convert it back, among many other uses.
The system is built around a TMS 320 F28335 TI-DSP microcontroller, which has an intelligent algorithm to handle application-specific voltage, current and power regulation. The grid frequency synchronization using advanced PLL algorithm for reliable connection with the grid.
The platform has a capability to configure grid requirement for any country grid. Bidirectional operation for charging and discharging to make the system compatible with grid-tied or battery storage system applications.
In case of a failure of a stack, other stacks shares the load. The system operates without any interruption. This ensures efficient current sharing mechanism, redundant operation in case of failure of any inverter fails. Helps user to continue operation and serviceability without interrupting the load.
Highlights of some protection developed for stackable inverter: isolation protection, anti-islanding protection that prevents backfeeding inverter generated power to the grid in the event of utility outage, under overvoltage protection, among others.
During the design phase, there were several design challenges that we had to overcome, such as low magnetic size and power losses to meet new industry standard of high power density inverter complying safety standards, meeting the cost given by customer, master-slave concept to ensure reliable and efficient operation.
While testing, we had the challenge to test the inverter response in line and load transient, grid synchronization over wide voltage and frequency range, current sharing and redundancy, protection circuit verification. We also had the challenge to integrate multiple application and configurations within the same software.
Along with the distributed energy storage, a variety of additional capabilities can be achieved that benefit both utilities and customers alike.
After an arduous testing, eventually the stackable inverter was ready, meeting all the specifications. This indeed made our client happy.
Our goal to take first steps in the direction of a big change by actively participating in designing distributed energy storage system saw success with the hope that it will usher into cleaner and greener world someday.